Welcome back, everyone. I hope you can hear me well and see myself on the screen. We are just starting session 5 of the day, and it's about game-based learning and communication using the Tactile Board. If you have any questions during the presentation, you can send your questions using the Q&A box, and you can also send messages using the chat, and we'll do our best to answer them. So my name is Arthur Tile, and I am the presenter in this session, and I work for Offenburg University in Germany. So Mauricio, when you're ready, you can play the presentation. Thank you. Hi, everyone. Thank you for joining our virtual symposium. My name is Arthur Tile, and I am a researcher at the Offenburg University in Germany. The title of my presentation is Game-Based Learning and Communication with the Tactile Board. Before I start, I would like to acknowledge the funding received from the European Union's Horizon 2020 program, and I would also like to thank the Suitcase Development Fund for supporting this symposium and some of the interpreters here with us today. In this slide, I show the logo of the Horizon 2020 program and the Suitcase logo. I would also like to acknowledge the work done by my colleagues at Offenburg University, in special James, who led the software development work in our research, Oliver, who has been involved in all scientific activities, Julia, who helped organizing this event, and Jonas, who supported the media work. And this slide shows pictures of James, Oliver, Julia, and Jonas. And at the bottom, there is the logo for the ACI lab and the logo for Offenburg University. So let me talk more about our work in the Suitcase Project. So most of our work is related to the use of technology and gamification to create interactive, fun, and meaningful experiences to the deafblind community. In my presentation, I will explore how we used haptic technology to foster, for example, independent mobility, enhanced communication, and social interactions for people with multiple sensory disabilities. So, what is gamification? Well, gamification, or also known as games for a purpose, is an approach for enhancing systems, services, or activities by using game elements or game principles in serious or non-game contexts. Gamification techniques apply people's natural desires for socializing, learning, competing, and just have enjoyable experiences. In this slide, I show a flow chart illustrating how the gamified experience works. And this includes emotions, the mechanics, and dynamics involved in gamifying different experiences. So why use gamification? Well, past research have shown that gamification can increase learners' engagement in the long run if gamification is applied to learning activities. It also has a positive effect on self-motivation, and it also can offer real-time feedback. And gamification can also make learning a playful and interactive activity. And here I show you an example of the Duolingo learning app. It's a popular mobile app for learning new languages that many of you may already know. And by using Duolingo, you can earn different scores and rewards that might motivate you to continue learning a new language. Another popular example of game-based learning is the Braille Play project. So the Braille Play platform is based on VBraille, which is a method for displaying Braille characters on a smartphone. And this project included 4 games of different levels of difficulty. And the aim of these games were to help children in learning Braille. And the researchers involved in this project were able to find evidence that children were actually able to learn Braille concepts efficiently after playing these games. So why to use gamification in the context of deafblindness? Well, according to past research, an estimate of 60% of adults living with deafblindness in the United States are not satisfied with their current recreational and social activities. And more than that, there is a need to identify the barriers related to the lack of recreational activities available to the deafblind community. And for us, there are many unexplored opportunities to using technology to create accessible, interactive, and fun experiences for people with sensory disabilities. So with that in mind, we designed the Keep Your Distance game and the haptic wearable. So the Keep Your Distance game was designed with the aim of teaching persons with deafblindness to navigate with a haptic wearable safely. So we wanted to make the learning experience more enjoyable for them. So this game involves 2 players playing together, where one player assumes the role of a secret agent, and this person is wearing the haptic wearable, and that would be the person with deafblindness. And the other player acts as a suspect that should be followed. And the goal of the secret agent is to keep within an optimal distance to the suspect. Getting too close to the suspect will expose the secret agent's cover, and on the other hand, staying too far away from the suspect will enable this person to escape. So how the person knows if they are too close or too far away? Well, we designed this haptic wearable that provides haptic feedback to the user. So the application that we developed uses a fisheye camera attached to this haptic wearable that tracks Aruco markers being held by a suspect. So through computer vision algorithms, we were able to estimate the distance and the angle to the marker. So depending on these 2 parameters, we can provide different feedback to the player. So we can provide different frequency levels of vibration. And that means quicker pulses mean the agent is getting too close to the suspect, and slower pulses mean the agent is too far from the suspect. So we placed different vibration motors on the belt area that indicate also the direction the player must move in order to follow the suspect. And here in this slide I show you two images. The first image would be the camera that collects all the data, and it's attached to the textiles of this haptic vest, and also the design of the 5 vibration motors that are placed on the belt area that indicate the direction the player needs to follow. And now I'm going to show you a short video that explains how the game works. The video has all the description, and it shows a person wearing the gaming vest.
Keep Your Distance is a playful haptic navigation wearable for individuals with deafblindness. The wearable was designed to encourage individuals with combined sight and hearing impairments to navigate independently in a gamified scenario where they are expected to chase a suspect by following haptic signals. To win the game, the user should keep an optimal distance of 1.5 meters from this person. A fisheye camera is attached to the vest and detects Aruko markers being held by the suspect. Directional and proximity feedback is then provided via 5 vibration motors around the waist area. The frequency of vibration also indicates whether the user is too close or too far from the suspect. Additional actuators are placed on the shoulder area and indicate when the user needs to start and stop walking. With Keep Your Distance, we aim to create a playful experience to the deafblind community by exploring the potential of intuitive body-worn haptic communication.
So the vest that is shown on the video is actually the old version of the vest. Our colleagues at the University of Borås have designed a new version for this, the Keep Your Distance haptic vest that I show you right now. You can see here the fisheye camera attached to the vest that collects environmental data that are then translated into vibrations on different parts of the body. On the belt area, there are 5 vibration motors that indicate directional and proximity feedback to the user. On the shoulder area, there are 2 vibration motors that provide stop and start walking vibration signals. And the latest addition to the vest is located on the back. We have implemented 16 vibration motors that can provide more complex messages to the user. And because we have a higher number of vibration motors, we can display different haptic patterns that can mean and communicate different things to the user while they are playing the game. And also we have the power and controller components located on the back. So we were able to test the Keep Your Distance game and the haptic wearable with 5 persons with deafblindness, and this was just before the COVID-19 pandemic. They were asked to complete a walking route and keep a distance of 1.5 meters from the researcher in order to win the game. And we actually were able to find some interesting results. So some of the key findings are that the directional and proximity haptic feedback was intuitive and easy to learn to all participants. Also, all participants enjoyed the playful experience and they were open to try the game again. And all participants were also confident enough to navigate independently when continuous feedback was being provided. Another interesting thing that we found is that some participants actually found that the haptic wearable would be useful during the the COVID-19 pandemic, because they can receive distance information about the people around them. And using this haptic wearable, they would be able to find out if the person in front of them is keeping enough distance that is aligned with the social distancing guidelines during the pandemic. But let's switch topics a little bit and talk more about how technology can support social interactions for people with deafblindness. We were interested to include the deafblind community in our technology design process. So we conducted a CoDesign workshop focusing on technology enhanced social interactions. And for this workshop, we invited persons with deafblindness, interpreters and family members, and researchers interested in the area. And some of the questions we were interested to know more about were how can we design better technology that supports communication for persons with deafblindness? In what social contexts should technology be used? And what are the requirements and user needs when it comes to technology-enhanced communication? And here in this slide, I show a flow chart that explains the co-design process. And this includes, for example, framing the issue, generating design ideas, and sharing experiences. So during the workshop, participants with deafblindness shared a number of experiences and requirements that they would like to see in a communication device. So some of our key findings include, for example, people with deafblindness would be interested in the ability to join in a two-way or group conversation. Also, another requirement would be the ability to initiate social interactions without the direct need of an interpreter. Right now, many persons with deafblindness need an interpreter to mediate conversations with other people. So they would like to be able to initiate social interactions without the need of another person. And also something that we were able to find in this workshop is that if we were to design a assistive tool, they would like to be able to use their preferred way of communication. We know that the deafblind community is a diverse community, and different people have different modes of communication. We have verbal communication. Some people prefer text-based communication, sign language, and tactile sign language. So they would like to continue using their preferred way of communication if they were using a communication device. So based on the user experiences shared during the workshop, and we developed the Tactile Board. The Tactile Board is an augmentative and alternative communication device. This mobile application communicates with the gaming vest that I showed you before, but you can also communicate with other haptic interfaces. The Tactile Board allows communication via haptic signs, text, and speech. And the Tactile Board was designed to foster social interactions between users with deafblindness and other individuals without the direct need of an interpreter. And here I show you different images of the mobile application and the haptic vest that is connected to the tactile board. So here I'm going to explain a little bit more about how it works. So with the tactile board, we have a mobile application where any person can draw a haptic sign on a screen, but also you can type messages or you can speak different messages with voice recognition, and then these messages will be translated into vibration patterns known by the user. And you can see in the middle here the vibration motors that display these messages through vibration patterns. And then the person with deafblindness receives the haptic message on the back and can reply using the same device. And as I said before, with the tactile board, it supports different modes of communication. So now I'm going to show you different videos that explain how people can use the tactile board differently. So for the first example, I'm going to show how people can use haptic signs to vibration patterns. And the message shown in this video is a man is talking on the screen. So in the video on the left, you will be able to see someone using the mobile application and sending a message. And on the right, you will see someone wearing the haptic wearable and receiving a message through vibrations. And in this example, the person will be using haptic signs that are based on the Danish haptic signals. So the person draws the haptic sign on the screen and it's sent as vibrations on the back of the user. So the second example that I'm going to show you is a text message translated into vibrations. The message is a woman is smiling, and this person can type the message into the mobile application, and then it's automatically translated into vibrations to the user. And again, the user is receiving vibration patterns that are based on the Danish haptic signals, but it can be personalized. And the final example that I want to share with you right now is the ability to use voice commands or speech to send the messages as vibration patterns. And in this last example, the message is a person is typing, and the modality is speech recognition to vibration patterns. So I can play the video.
A person. Is typing.
So in this example, the person is communicating using English, but because we use Google's natural language processing API, we can support other languages as well, depending on the language used by the user. So these were the examples of modes of communication that are supported by the Tactile Board, and they are all translated into vibration patterns that are displayed to the person with deaf blindness wearing the haptic wearable. So we are now in the last part of my presentation, and I want to talk more about how gamification and technology can support learning. So in my previous examples, we have seen many haptic signs. So we have been talking about social haptic communication signs. So how does a person learn new social haptic communication signs? And here I show you a picture of someone using haptic signs on the back of a person with deaf blindness. So how can a person learn these signs? And also, more importantly, how can technology support social haptic communication learners? So in order to answer this question, we have developed a mobile game to help people learn social haptic communication signs by using vibration patterns that mimic different signs. So the mobile application that I show you here is connected to a haptic chair that vibrates different haptic signs on the back of the user. And the user then has to guess them correctly. So the game was designed and developed by a student called Jessica Vuik, a student from the University of Twente in the Netherlands. And this project is a collaboration between our team at Offenburg University and our project partners at Eindhoven University of Technology. So on the left, I show you an image of the game interface and 4 options that the player needs to guess correctly. So it's a quiz-like game interface. And each of the options represent a different haptic sign. And on the right, you can see an illustration of the haptic chair that has 9 vibration motors that are connected to the game. And the haptic chair was designed by our colleagues at University of Borås. So I'm going to show you a short demonstration of how the game works. So in this slide, I will play a short video demonstration of the game in action. In this video, a person with deaf blindness is playing the game, and the video shows a person sitting on the haptic chair and trying to guess the correct haptic sign using the game interface. And because this person has low vision, she is using audio descriptions of the different options being shown on the screen. So here I show you the person playing and trying to guess the correct haptic sign that is being displayed on the back. And she's trying different options, and once she's able to recognize the correct option, she receives a message that she is right. And then she earns different points and can continue playing the game and guessing different signs. So this project is still ongoing, and the mobile game is still under development, but it has shown some exciting results so far. The mobile game can be played by persons with deaf blindness, but also it can be played by family members who want to learn social haptic communication, or interpreters in training. And some of the interesting aspects of game based learning is that players can compete against each other and earn points while they are learning. So before I finish my presentation, I would like to go back to this flow chart that summarizes our work in the Suitcase project. So during my talk, I showed different examples of how haptic technology and gamification elements can be used to support and enhance, for example, independent mobility, social interactions, and learning for people with multiple sensory disabilities. So this concludes my presentation. I would like to thank all my colleagues and project partners who collaborated in this work. And before I finish, I would like to bring attention to the Suitcase Project documentary that was made by a group of media students at Offenburg University. If you are interested to know more about the project, you can search for the Suitcase Documentary on YouTube. I will also post the link to the documentary in the chat. Thank you very much. Right. Thank you for joining my presentation. We have a few minutes for questions, and we actually have some questions. I will try to read them out loud. Let me find them. So the first question is a question for the Tactile Board. I may just have missed that. Can a deaf-blind person use the app user interface? Yes, we designed this mobile application thinking about all the diverse sensory characteristics of the users. So we actually support audio interaction, visual interaction, but also tactile interaction. We have designed a tactile cover for the tablet or for a smartphone that allows deaf-blind users and blind users as well to interact with the interface by tactile exploration. And this textile cover was designed by our colleagues in Sweden at the Swedish School of Textiles. So through these tactile overlays, the person can use the touch screen by tactile explorations. I hope I answered your question. We have other questions. So Jeremy said, this is fascinating work, thank you. If I follow correctly, the vocabulary shown here is a custom one you developed, in which various patterns are more phrase-sized rather than chunked at the levels of individual words. Can you tell us more about the size of vocabulary? So yes, for this example that I showed in the videos, we were using the Danish haptic signals, and these are existing signals that are published, and you can find them online. I believe it consists of over 100 haptic signals, but we also have different versions for other countries. I believe Mirta mentioned the Dutch social haptic signals. We also have the Finnish signals, and I believe this varies by country. But right now, I know that for sure the Danish handbook has over 100 signals. But for our testing in our lab, we were able to translate actual social haptic signals into vibrations. We tested over 50 different signs. But the other part of the question is the learning times required before users are able to achieve higher recognition rates. We were not able to test the interaction over time, mostly because of the COVID-19 pandemic restrictions. So we were not able to test, to do proper long-term testing with users, but we are planning to do it so we can then investigate the learning curve over time. The third part of the question is the effective rate of communication that is achievable with the system. As I said before, we are still aiming to evaluate that with real users. But going back again to the vocabulary, for this example, we were using Danish signs, but the user can create and customize their own signs. For example, if this user is not fluent in social haptic communication, they can create their own signs. It doesn't have to be based on an existing vocabulary. I hope I answered your question. We have another question that is, can one use the apps with a mobile Braille display or keyboard? This is actually a good question because we are still developing this part. Right now, people can use the app with screen readers, like the mobile screen readers. If you are using Android, you can use the TalkBack screen reader, but also if you are using, for example, iOS, you can use Siri, but Braille displays is something that we are planning to develop further. Do we have any other questions? Let me see. I know that Femka was saying that the Keep Your Distance game was perfectly named for the pandemic time. Yes, actually, because we designed this game just for creating a playful and fun experience. But when we were testing it with people, they actually said, well, this is also useful for the pandemic because I can use the camera and the haptic feedback to see if other people are actually following the social distancing guidelines. So Rita has written in the chat, there are different levels of social haptic communication. First level are based on touch messages, which we all used, like stop. Other levels are agreed haptices, as we agreed to use words or sign language. Yeah, so our main goal with the tactile board was to give this opportunity for people with deafblindness to initiate casual social interactions without the need of an interpreter in cases they don't have an interpreter available. So for example, in the case of an emergency, they can if they are wearing this haptic wearable, they can just use their phone and send a simple message to other people, and people will understand because it's translated automatically to speech or text. So this is kind of the context that the tactile board can be used.
Arthur, I think we don't mention anything about one-to-many facilities that have been created. Maybe you like to say something about that, and this tactile board can be used for that too.
Yes, so another thing is that actually was mentioned during the workshop we conducted with people with deaf blindness was that communication by someone who is deafblind is always one-to-one, you know. Usually it's a person with deaf blindness communicating with an interpreter, and then the interpreter can communicate to others. So it's always one-to-one communication. And one of the goals of our project was to use technology to support one-to-many communication. So the person with deaf blindness can communicate to more people other than the interpreter. So with the tactile board, for example, they can send a message that then is sent to more people in the room. But also, if, for example, if we have more people with deaf blindness wearing a haptic vest, then this message can be sent real time to multiple people with deaf blindness, and they will all receive the vibrations on the back. These are some of the contexts that one-to-many communication can be supported by using the tactile board. And also, I know that some colleagues, they are interested, for example, in using one-to-many communication in learning environments, for example, at schools, and also for example, conferences. If, for example, if you have a group of people with deaf blindness, they are all wearing a haptic vest, then you can easily use the tactile board to send message to everybody without the need of multiple interpreters, for example. But one limitation actually is that all of them need to be able to understand this vibration pattern that being displayed. So that's why in this demonstration that I showed during my presentation, we were using standard Danish haptic signs because then, for example, it's easier for them to learn. But as I said before, personalized signals can also be supported by our system. I think we have 1 minute left. Let me see real quick if we have other questions. I don't think so. I think Nazreen shared the link to the Danish haptic signals in English. So if you are interested, you can download this ebook, and it's quite helpful. And I think that's it. If we have other questions, I can answer them later using the chat. So we have a 15-minute break, and we'll be back for our final session of the day. Thank you very much.